Compound pendulum. What is compound pendulum? Okay, we will study about compound pendulum. What is compound pendulum? A compound pendulum consists of a compound pendulum consists of a compound pendulum consists of a rigid body consists of a rigid body which can oscillate which can oscillate freely about a horizontal axis passing through it. Okay? Compound pendulum. What is compound pendulum? A compound pendulum consists of a rigid body which can oscillate freely about a horizontal axis passing through it. A compound pendulum consists of a rigid body which can oscillate freely about a horizontal axis passing through it. Okay? Time period of the compound pendulum. Time period of the compound pendulum. Time period of the compound pendulum. Okay. Consider a rigid body of any shape. And mass m capable of oscillating freely about a horizontal axis passing through it and perpendicular to its plane. Let O be the center. Let O be the center of suspension of the body, and G is the center of gravity. Vertically below O at a distance L. In the position of rest. Okay. When the body is displaced through a small angle theta to the dotted position, the center of gravity is shifted to the position G dash, and its weight mg acts vertically downwards. If the pendulum is now released, or restoring couple acts on its and bring its back to inertial position. Okay, initial position, but due to inertia it overshoot the mark. And hence starts oscillating about the mean position. Oscillation about the mean position. The moment of restoring couple are torque. Then the moment of the restoring couple are torque tau equal to minus mg cross G dash capital A equal to minus mgl sin theta equal to minus mgl theta. Okay, since the angle theta through which the pendulum is displaced is small, so that sin theta equal to theta. Okay. The restoring couple gives rise to an angular acceleration alpha in the pendulum if I is the moment of inertia of the rigid body pendulum about an axis passing through its center of suspension. Then restoring couple is given by tau equal to I d square theta upon d t square, because tau equal to I into alpha. Okay. Then comparing equation, this is the equation number first, and this is the equation number second. Comparing equation first and second, I d square theta upon dt square equal to minus mgl theta. Okay. Then d square theta upon dt square equal to minus mgl upon I into theta. This is the equation number third. Okay. This is the equation number third. Then d square theta upon dt square is directly proportional to theta. Because mg minus mgl upon I equal to constant. Okay. Then as the angular acceleration is proportional to angular displacement, the motion of the compound pendulum is simple harmonic, and it is time period t gives by t equal to 2 pi under root of angular displacement upon acceleration, that is t equal to 2 pi under root of angular displacement theta upon angular acceleration is mgl theta upon I. Okay. mgl theta upon I, that is 2 pi under root of I upon mgl. This is the equation number 4. Okay. If Ig is the moment of inertia of the body compound pendulum. Moment of inertia Ig is the moment of inertia. Ig is the moment of inertia. Ig is the moment of inertia of the body. Moment of inertia of the body are compound pendulum. Okay, about an axis parallel to the given axis, but passing through CG. Then according to the theorem of parallel axis, according to the theorem of parallel axis, according to the theorem of parallel axis, I equal to Ig plus m I square. Okay, Ig equal to mk square, where k is the radius of gyration. Okay. Then I equal to mk square plus m ml square equal to mk square plus l square, and substituting the I in the relation 4, we have t equal to 2 pi under root of k square plus l square upon lg. This is equation number 5. Maximum time period. Maximum time period. What is maximum time period? The time period of the compound pendulum is minimum time period. Minimum time period. The time period of the compound pendulum is minimum when the distance of the points of suspension from center of gravity is equal to the radius of gyration. To prove this, put a relation for the time period t equal to 2 pi under root k square plus l square upon lg as t square equal to 4 pi square upon g under root k square plus l square upon l, okay, equal to 4 pi square upon g under root k square upon l square plus 1, okay. Differentiating this equation with respect to L, then this is 2 pi, 2c dt by dl equal to 4 pi square upon g minus k square upon l square plus 1, okay. For the value of time period t is minimum, dt upon dl equal to 0, for the value of time period t minimum, for t is minimum, okay, t is minimum. Then 1 minus k square upon l square equal to 0, or l equal to plus minus k, okay. Further dt square upon dl square, further d square capital T upon dl square comes out to the positive if l equal to plus k. Then T minimum equal to 2 pi under root of k square upon k plus k upon g equal to 2 pi under root of k plus k upon g. That is a T minimum is 2 pi under root of 2k by g, okay. This is the minimum. So the time period of the compound pendulum is minimum when the distance of the point of suspension from center of gravity is equal to the radius of gyration, okay. Thank you. Next is our Trojan pendulum.